The Sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the Sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the Sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the Sun gives off. Thankfully, the amount of visible light the Sun gives off doesn't change very much. That would be a serious problem. If the Sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the Sun is. The more sunspots that are visible, the more active the Sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the Sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm, like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The Sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the Sun. High-speed electromagnetic plasma gas from the Sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the Sun, but they aren't dark. They're just not as bright as the surface of the Sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the Sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the Sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the Sun associated with sunspots. As the superhot plasma gas on the Sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the North and South Pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the Sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the Sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the Sun's surface. The corona of the Sun is much hotter than the surface of the Sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the Sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the sun. Cool, huh? Turns out the sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California that keep a constant watch over the 10 million sound waves moving on and around the sun. Now that the sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the sun is a bit concerning when trying to predict how active the sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the sun. It is as if the magnetic distortions we usually see on the photosphere of the sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.
In July, when we're about 94 million miles from the Sun, the world is about 36 degrees Fahrenheit warmer overall than in January, when we're 3 million miles closer. This is because there's more dry land in the northern half of the planet than the southern half, and land tends to heat up more than water. During the northern summer in July, more land is heated up than in January. So the planet gets a little warmer at this time, even though we're further from our source of heat. The closer the moon is to the horizon, the larger it looks. This phenomenon is called the moon illusion. One of the theories explaining it claims that the atmosphere plays the role of a magnifying glass, which makes the moon look bigger. In reality, if the atmosphere had a say in it, the moon would actually look smaller, not bigger. Most experts believe that the illusion is created by your own mind. It can increase the moon's size more than twice. When Earth's satellite is high up in the sky, you don't have any visual cues about how far away it is. But when it's near the horizon, you can see objects surrounding it in detail. It makes the moon look larger. but it's just one of the many theories explaining the phenomenon. By the way, you can trick yourself out of this illusion if you bend down and look at the moon upside down through your legs. A day on Venus is longer than a year. It takes the planet 243 Earth days to rotate around itself, and only 225 Earth days to make a full circle around the Sun. Around 5 million years ago, the supermassive black hole at the center of our galaxy launched a star from itself, and it's now traveling through the Milky Way 10 times faster than any other star out there. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface showing that it's getting smaller. After more research, they found out that Mercury hasn't finished cooling down yet. The Earth and the Moon are gradually drifting apart, as slowly as your fingernails grow. This is the flip side of our satellite's gravitational force. The Moon creates tides in the Earth's oceans. They pull back at the Moon and make it speed up. This in turn moves the satellite to a higher orbit. In prehistoric times, the Moon was way closer to our planet than it is now. Luckily, we aren't going to lose the Moon. The farther away it moves, the weaker its gravitational pull becomes. It means that soon, our planet won't be pushing the Moon away with such a force. Discovered in 2017, Kelt 9b is the hottest planet we know of. Next time you're complaining about the heat on a scorching summer day, just remember that temperatures on this planet can reach 7,800 degrees Fahrenheit. That's because it orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our Sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? Everything on Earth, and everything people have managed to see in space with the help of telescopes and other instruments, is normal matter. It's made up of atoms and molecules, and adds up to less than 5% of the universe. Almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if several decades ago they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant there had to be some enigmatic force that counteracted gravity. It got dubbed dark energy. Cold welding is a phenomenon in space when two pieces of the same metal join together without any trouble and heat. About 700 million years ago, a mysterious event that occurred may have turned Venus into the place it is now. Admittedly, astronomers can't see the surface of the planet directly because it's covered with dense layers of thick clouds. But space missions that have been sent to the hot planet found that Venus is peppered with fire-breathing volcanoes, massive mountains, countless craters, and gigantic lava plains. The temperatures on the planet are so incredibly high that they could melt lead, and the atmospheric pressure is so immense that it would instantly crush any living being reckless enough to set foot on it. If that's not enough, the atmosphere of the planet is filled with noxious clouds of sulfuric acid, which smells worse than rotten eggs. Carbon dioxide, the main component of Venus's atmosphere, along with the infamous sulfuric acid, create a powerful greenhouse effect. As a result, the lower atmosphere and the surface of the planet are some of the hottest places in the whole solar system. Neutron stars are the size of a small city, yet their mass is about 1.4 times that of the Sun. They're formed when massive stars die and their cores collapse in on themselves. The core continues to press in on itself until all the electrons are essentially crushed together, leaving only neutrons. This makes neutron stars one of the densest objects in the universe. In fact, a single teaspoon of neutron star material would weigh 1 billion tons. Of course, getting this sample and delivering it back to Earth might be a difficult task, since the gravity on a neutron star is 2 billion times stronger than the gravity on our planet. Because of the effect the Moon has on Earth, our planet is gradually rotating slower and slower, and I mean very gradually, at around 17 milliseconds every 100 years. So, it will take 140 million years before the world can add a single extra hour to its day. But that also means that when the dinosaurs existed, there were only 23 hours in a day. There's very little activity going on inside the moon. Plus, there's almost no atmosphere around. That's why scientists can trace impact craters littering the satellite's surface back billions of years. While dating the craters, astronomers discovered that the moon, along with our planet, went through a late heavy bombardment about 4 billion years ago. This event is also known as the lunar cataclysm. This interval lasted several 100 million years. During it, an unusually large number of asteroids collided with Earth, Mercury, Mars, and Venus. The newest scientific theory claims that Venus could have had a pleasant, stable climate for billions of years before something went wrong. Astronomers did thorough research and built a model of a virtualized Venus-like world. This model demonstrated that for most of its history, the hot planet had oceans with liquid water, adequate temperatures, and stable tectonic plates. In fact, the planet resembled Earth as it used to be at the beginning of its life. Scientists suppose that this period of Earth-like development could have lasted for more than 3 billion years. Saturn is a planet with winds that travel at more than 1,100 miles per hour at the equator. It's also the planet with the most prominent rings. The atmosphere of Saturn isn't really different from its surface, but the deeper you go, the higher the pressure becomes, and hydrogen becomes liquid. Further to the center of the planet, this liquefied gas turns into metallic hydrogen. Like Jupiter, Saturn might have a rocky core, with hydrogen and helium surrounding it. On the other hand, even if it is made up of rocky material, the core can still be liquid. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique systems of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. The sky might appear pretty peaceful as you look at it from Earth, but the Milky Way is headed for a massive collision with the Andromeda Galaxy. 4 billion years from now, you can set your alarm. These galaxies will meet, and neither will survive. Stars will be scrambled, and constellations will be undone. Eventually, the two giants will merge and form an elliptical galaxy. But according to National Geographic, our Sun and Earth will survive. Any life forms on Earth will be treated to a splendid sight as the galaxies come together. The Sun isn't technically the center of our solar system. It's in a space called the barycenter. It depends on which planet you're standing in. The barycenter is usually closest to the object with the greater mass. So, since we're on Earth, the true center of the solar system is the Sun, but not the center of it. With respect to Jupiter, the barycenter is actually outside the Sun's surface. Jupiter is 318 times bigger than Earth, so the balance is different. The planets don't really revolve around the Sun, but around their common center of mass. Imagine balancing a pencil on the tip of your finger. You'd have to place it right in the center so that it doesn't tip on each side. Because the pencil has its mass equally distributed, it's easy to assume that everything balances its way like that, especially in outer space. But try balancing a hammer on the tip of your toe. Chances are you'll walk out of here with a broken toe. Its true barycenter is close to the hammerhead rather than the actual center where you'd grip it. Earth and the Sun's barycenter is like that hammer. The center of mass is more or less in the center of the object. Realistically, if the Sun were to rotate around Earth, then our little blue planet would have to be just as big as the Sun, or bigger. We can't disregard the other planets in our solar system, which means they all will have to rotate around us as well. But in the ancient days, bright minds always thought everything revolved around the Earth. They called this the geocentric model, and this made sense to them because it looked like everything above us was spinning around us. The Sun and the Moon played vital roles in human history, and we didn't feel insignificant in the universe until way later on. In ancient Greece and the Middle Ages, The big brains used the geocentric model to study space. It wasn't until the 16th century that that model changed. Back in those times, they couldn't even imagine that everything revolved around the sun. And they didn't have the knowledge to back any of this up. The Earth can't be the center of the solar system because it's not large enough for the job. For the conditions to suit the enormous size, life would have evolved differently. We'd probably be less dependent on oxygen. Some animals, like whales and dolphins, can stay for hours without taking a single breath. They can even sleep underwater. So the humans of the sun-sized Earth would have specialized lungs and wouldn't need to constantly be taking in air. It means that the plant life would be limited, with just a few shrubs here and there. There are trillions of trees around the world, but the main contributor to producing oxygen is the algae in the ocean. With such vast real estate of oceans and seas, the algae sitting on top are pumping out the air we breathe. Oxygen wouldn't be so abundant on this planet, but our breathing mechanisms might rely on carbon dioxide, another common gas found on other planets. If the planet is hot, then water will be scarce. We would only find it on certain parts of the planet, like mountaintops. The ground would be too scorched for anything to survive in properly. We can forget about seasons as well. The sun is currently just large enough to give us what we need. But since the Earth would be so large, and the sun would be another celestial body emanating heat, we'd always feel like we're inside a microwave. The days and nights will be different, and not much precipitation will happen. With so much heat produced in the core, earthquakes and volcanoes would likely erupt all the time. The surface would practically be a scorching plain of red magma floating around. This would be the true red planet. But if we had the same landscape like on Earth, living somewhere near the mountains could save you. The mountains would still be embedded in the core, but it would be better than staying on the ground. Some of the mountain peaks could even be 100 times taller than Mount Everest. The canyons could be so deep that the Mariana Trench would feel just like a little rupture. Animals would also behave and look different. Cold-blooded animals would have to soak up as little sun as possible so they don't burn. Animals would have to rely on migration to find water in distant lands. Birds can fly for hundreds of miles for migration season, so we'd probably see certain sleek-looking birds speeding through the air. But because gravity would be so strong on the colossal-sized Earth, the flying animals would need thinner bones and a thinner core just to take flight. The real survivors would be the microorganisms. They can live in extreme temperatures and pressures and can live without oxygen for a good while. The nights would be dark since there wouldn't be any moon to reflect the sunlight. The moon would most probably be on the opposite side of where the sun is shining, so it would forever be a floating ball in the sky. The Earth's rotational speed is the fastest at the equator, so if all the planets and the sun rotated around us, then our rotation wouldn't be so significant. New weather patterns wouldn't be good for crops. Humans would have evolved differently from what we are like now. We'd probably be shorter and stockier since gravity is so strong. And because of the soaring temperatures, we'd probably live in caves all around the world. The strongest ones would have migrated to the mountains. We'd probably have the same evolutionary path as we do now, but other physical features might be different. Our pigment would likely look different to combat the heat. The desert fox has large ears for hearing out predators and for cooling itself down in the scorching desert heat. It's possible that we would also have bigger ears than what we have now for the latter reason. We'd be a lot stronger than we are, and our bones would be thick and tough to break. Gravity is one of the key components to developing our bone density and muscle mass. This means we would unlikely need tools for hunting. This would have delayed the Bronze Age and modern civilization as we know it. With little vegetation, standing upright wouldn't be so necessary to find predators around us. We wouldn't be the fastest runners either, but we'd be strong enough to fight off a pack of strange-looking wolves. And if the Earth was supersized, then it's possible that multiple species of humans would be roaming the land in isolated areas. Some human species would grow and evolve into the intelligent thinkers of today, but some would remain the same. And some creatures from the past would still be around, unchanged. Sharks would have been around since the dinosaurs era. They wouldn't have to change their form or adapt because of their dominance. Other animals would remain the same because of their isolation. The Galapagos Island hosts some unique animals because they've been alone for so long. Without proper predators constantly lurking around them, they don't fear humans. The new mega-sized Earth would have areas as large as Asia filled with isolated animals that could remain the exact same as when they first appeared. The human species of those regions would also remain the same, since they wouldn't have moved or experimented with anything. Their diet would remain the same, and they would get used to the climate they're in. Technology would also have flourished differently in various parts of the planet. With some areas in complete isolation, they wouldn't have access to new gadgets and inventions. It would be like living on a planet with different eras in the present day. Other areas would be so advanced, they might even be flying themselves outside the planet in search of truth and answers. Our gravity is good enough for us to live properly and develop life, but if we pumped up our size to that of Jupiter, then gravity would crush us. And being the size of the Sun, Earth wouldn't even be a planet, but a brown dwarf, and would constantly be burning until it became a new sun. As of now, Earth is so small in our universe that we're practically like a grain of sand in the desert. On a cosmic level, we're an insignificant contribution to this universe.